Okay, Unit 6, Lesson 1, Inequalities. We're just going to start by talking about the basics. Okay, so this little weird E symbol means an element of, and then W means whole numbers. Okay, whole numbers are numbers that start at 0 and then going up. Those are whole numbers. Okay, this means an element of and then natural numbers. So natural numbers start at 1. So the only difference between those two is that whole numbers include 0. Element of the I means integers. So now integers also include negatives. So, and then all the wholes as well. So they're integers, and then the R is real numbers. So real numbers include all of the above, plus like decimals, fractions. I wanted integers. So the integers plus decimals. What do these symbols mean? This means less than. This symbol would mean greater than, less than, or equal to, greater than, or equal to. Okay, recall graphing lines from grade 10. So in grade 10 you learned mx plus b, slope-intercept form. Okay, so the b represents the y-intercept, and m is the slope, which is rise over run. So here our intercept is -5. 1, 2, 3, 4, 5. 2 is 2 over 1. So we're going to go up 2, right 1. Up 2, right 1. And that's the line. Okay, you also learned to do intercepts. So if I cover the y term up, 2x equals 12, so x would equal 6. And then if I cover this x up, I get negative 4y equals 12, so y equals -3. And then there's my line. Okay, I'm also going to show you that I would like you to learn how to move them around. So I'm going to keep the y term, and I'm going to move the x. And then I'm going to get y alone by dividing everything. So y equals, so this would be 1/2 x. 12 divided by -4 is -3. So this starts at -3 as an intercept. Up 1, right 2, up 1, right 2, up 1, right 2. Like you can see that it's the same line. Okay, graph. Y is less than -x plus 6. So 1, 2, 3, 4, 5, 6 is our intercept. We're going to go down 1, right 1, because it's a -1 slope. Okay, so those are the points on our line. So this line is less than. So we are going to draw it as a dashed line because we cannot be equal to the line. And then less than means we're on this side of it. So any point in that region would be a solution. So for instance, 0, 0, 0 is less than -0 plus 6. That's true. Okay. Next, we're going to isolate y. So I'm going to keep the y term, move the x. Okay, now dividing by -1 is going to do something special. It's actually going to flip our inequality around. So if you divide or multiply by a negative number, when you're doing your algebra, you have to flip. So this becomes 3x and -9. So up 3, right 1. And now this says we can be equal to the line, so I'm going to draw it as a solid. But at the end, we end up less than, so less than is angling downward this way. Okay, so we could also double check here if we cover this up. X-intercept is 3, and if we cover this up, the y-intercept is -9. Okay, so this is the same line, but what if x and y were element of the integers? So what difference does that make when you graph it? So same line, same dashed. Now if they're integers, so we're below, so we're on this side of it, we're less than it, but this time you have to stipple. Your solution is that you are telling me that it's any points in this region. Okay, obviously it goes on forever, but I'm not gonna, that would take me all day. Okay, so any of those points would be solutions. Okay, and then, so this is the same line. And then we're on this side of it. But whole numbers mean that you can't go below 0. So how would that change the solution? It would now be like this. I mean, if I kept going, you could see that. Okay, so you're on that side of the line, but now you can't include these points because they're not whole numbers.